Okay, guys, so you should have gotten this pod. You should have worked on it before starting to watch this video. I'm going to go ahead and go over the answers. Make sure this graph gets glued into your pod notebook. And hopefully you wrote down the full question. But we need to find the median mark. So as we know, the median is, it represents the number that we have. We have 100 students. So this is going to be 50.5. Now that doesn't tell us exactly what the median is, it just tells us where to find it. So I'm going to go with 50.1. I'm going to go ahead and make this as thin as I possibly can. And 50.1 is going to be right up there. Draw this line over to where it hits the curve. And then I'm going to drop down in perpendicular to see exactly what value that is. It's perpendicular to make it. And I'm looking at somewhere around 50. This clearly is going by twos, 2, 4, 6. So my median is 56. Okay. To find my interquartile range, I need Q1 and Q3 because it is indeed the difference between the two. Okay. And so that's how I want to use the formulas to go about figuring out what Q1 is, and also to figure out what Q3 is. Okay, so I'm going to go there on my graph. So I'd say my Q1 is about 40. My Q3. About 70. Okay, so I can say that Q3 is 70, Q1 is 40, so my interquartile range is 30. Remember, 30 is the interquartile range basically tells you where the middle 50% lie. So basically 50% of your data lie from basically from this point all the way to this point. Okay, so hopefully you guys did well on that. You are going to be taking some notes on variance and standard deviation. Hopefully you got the notes on that as well. But basically, variance combines all values in a data set to produce the measure spread. It's the arithmetic mean of the squared difference between each value and the mean value. Okay, so it's basically the arithmetic mean of the squared difference between each x value and the mean value. So basically, you would take every x value, subtract it from the mean, you would square it, and basically do the average of all those. So you add them all up and then divide by however many you have. That's how you go about finding variance. Okay. So squaring the difference between each of the values and the mean values has 3 advantages. Okay. It makes each term positive, so the values above the mean do not cancel out the values below the mean. It also squaring adds more weight to the larger differences. In many cases, this extra weighting is appropriate since points further from the mean may be more significant. And then lastly, the math is relatively manageable when this measure is subsequent statistical calculations. So there's a little bit about variance there, so you guys have an idea. Remember that variance is the square of standard deviation. As you can see here, standard deviation is the square root of variance. So variance is standard deviation squared, and of course it has the same units as the data. Standard deviation shows how much variation there is from the mean and gives an idea of the shape of the distribution. Okay, so lower standard deviation show the data tends to be closer to the mean, versus a higher standard deviation shows that the points tend to be more spread out over a large range of values. Okay, so here's an example of what exactly I mean by that. A lower standard deviation, meaning the smaller the standard deviation, you have basically more of your data is closer to the mean. Okay, because that basically means, remember when we were talking about normal distribution curves back in the probability unit? Basically that means that everything's going to be really close together. However, a higher standard deviation, a bigger standard deviation means it's going to be more spread out further and further away from the mean. Okay? Now, the properties of standard deviation deviation is only used to measure spread or dispersion around the mean. Standard deviation is never negative, it's always a positive number. And it is sensitive to outliers, which basically means that if you have a random piece of data that's like so far away from the majority of the data, then it is going to adjust your standard deviation. For data with approximately the same mean, the greater the spread, the greater the standard deviation. And if all values in the data set are the same, the standard deviation is 0 because each value is equal to the mean. So basically, if you had 100 pieces of data, but they all were 85, well then the standard deviation will be 0 because everything is equal to the mean, because the mean will be 85. Now, the effects of different changes to your data. Sometimes you may be asked to, they might only give you that, this is the mean, this is standard deviation, and then it says, hey, 5 units were added to each piece of data. What is the new mean, what is the new standard deviation? Kind of like that question was in your midterm. So basically, if you add or subtract, it works both ways. So if you add a number or subtract a number to or from all the numbers in the list, then the mean is going to increase if you add, or decrease if you subtract by whatever that number is, but the standard deviation is going to remain the same. Okay, so if you add a particular number or you subtract a particular number, the standard deviation stays the same, but the mean either increases or decreases by whatever that number is. However, if you multiply or divide all the numbers that are in your data set by a number, by k, then both the mean and the standard deviation are multiplied or divided by that value. So let's take a look at that example from your midterm. I don't know if you guys remember this one, but it said a set of data has a mean of 20 and a standard deviation of 6. So it doesn't tell you what the data pieces are, it just tells you the information that you need to know. Now it says each value in the data set has 10 added to it. Now we have to write down the value of the new mean and the new standard deviation. Well, if you recall from the last slide, if it's added, then basically that number gets added to the mean. So our new mean is going to be 30, but our standard deviation stays the same, okay? And you can just kind of run it real quick. Like say you have 4, 5, 1, and 10, right? Say those are your pieces of data. And if we add this up, that gives us 20 divided by 4, our mean is 5, right? But if I add 10 to each of those values and add them up, that gives me 6 divided by 4, and then that'll give me 15. As you see, the mean was added by the number that you added to each data piece, okay? However, the standard deviation does stay the same. Each value in the original data set is now multiplied by 10. Well, if it's multiplied by 10, that means we're going to take our mean and multiply it by 10. So our new mean is going to be 200. And then it says find the value of the new variance. You have to be careful. Remember, variance is basically standard deviation squared, okay? So first off, since our data set is being multiplied by 10, we're going to take our standard deviation, multiply it by 10 to get 60. This represents our new standard deviation, but it's asking us for variance. Key word here. Variance is standard deviation squared, so we're just going to square 60, and we're going to get 3,600, and then that's our final answer. Okay? So that's that one from your midterm. Some of you actually got like all of A and like BI right. It was just, double I. Okay? So let's actually go about finding out what is the mean and standard deviation of a particular data set. I mean, it is pretty straightforward. There is a calculator way to do it. And so I'm going to show you guys the calculator way now. There will be a separate video of how you do it by hand. If anybody so happens to be doing anything related to statistics and you want to figure out the mean or standard deviation of some data for your IA, I will have a completely different video for you guys because you will need the actual by hand way, to actually be inside of your IA. So it's pretty straightforward. We just have to basically get all this data in, okay? And to try to kill 2 birds with 1 stone, I'm going to go ahead and make a frequency table because I don't want to have to type in all of this data, okay? So I know I have numbers from 0 to 9. Let's see. I I have 1 0 and 1 1, and I also have 2 2s, 3 3s. Yep, yeah, 3. Let's see, I got 4 6s and 5 5s, 4 6s, 3 7s, 3 8s, 2 9s. Okay? I believe all those numbers add up to be 30, and that they do. Okay? So basically what I'm going to do, I'm going to show you how to do it in your calculator. You'll be expected to know how to do it in the calculator for an exam, for homework, whatever. So I'm going to plug this in the L1, this in the L2. Okay? So I go to Stat, I go to Edit. As you see, there's L1, clear it out. L2, clear it out. Now, I clear it. I do not delete it, because look what happens. If you press delete, the column is gone. Okay, I think I've talked to you guys about this, but just in case you forgot, if you ever accidentally delete a column, all you do is go to Stat, go to Option 5, and click Enter. Basically, the setup editor brings back L1, as you guys can see. So I'm going to type in all these numbers into L1. Now, you don't necessarily have to do a frequency table like I did. I just didn't want to have to type in all 30 of these numbers, and heaven forbid I miss a number. Okay, so this is just another option. Okay, I got all my numbers in there. Hopefully that doesn't have to be 30. Hopefully I didn't make a mistake. So what I'm going to do is I'm going to go to Stat, over to Calc, and I'm going to go to 1-bar statistics. 1-bar statistics is going to allow me to basically pull up all the information about this data. So my list, I know my calculator probably was different than the majority of you guys, but I'll talk about both versions because you do need to know both. So list basically represents your X values. All my X values were in L1. Frequency list stands for my frequency, okay? So those that F column, that L2 column, that's going to be in my frequency list. So I'm going to press the second button, then I'm going to press the 2 button so that L2 shows up, and then I'm going to go to calculate. Okay? And then I have all this information. I have the mean of this data right there. That X bar represents the mean. Okay? So my mean is 5. And then standard deviation, as you guys remember, this is the symbol for standard deviation. So my standard deviation is 2.25 when I round to 3 significant figures. Okay? So my mean is 5, or you can even say, mean using the mu. And then my standard deviation is 2.25. And as simple as that. And if you're curious, that key 1 down there, and if you scroll down some more, yes, that is the information for your box and whisker plot. You could use your calculator as well to get the information for your box and whisker. Okay? So, but like I said, it is pretty straightforward. If you guys have any questions, by all means, you know how to get in touch with me.